Okay, so now let's talk about the second example. So in this case, we have this equation. Y double prime plus 3y prime plus 2.25y is equal to minus 10 e power minus 1.5x. So this is the non-homogeneous equation, and we have the initial value conditions. Y0 is equal to 1 and y prime 0 is equal to 0. So for this non-homogeneous equation, first of all we will find the solution for the homogeneous part. So the characteristic equation is m square plus 3m plus 2.25 is equal to 0. So this is a complete square, so m plus 1.5 square, okay, is equal to 0. So m will be equal to minus 1.5, and this is a double root, so the homogeneous part will have the solution constant c1 plus c2 x e power minus 1.5 x. So this is the homogeneous solution. For the particular solution, so since now we can see that this function rx also has exponential part with the same power minus 1.5x, which was the root of this homogeneous solution. And also because the homogeneous solution was the double root, it already has the x, so the experience has shown that we will have a particular solution which will have, of course, minus power minus 1.5x, but that particular solution will be then multiplied by x, no, not x, but by x square. Because x is already there, we have to go one higher power than that, and then it will give the solution. And then its undetermined coefficient we can determine as a. Okay, so now we assume that this is the solution, a x square e power minus 1.5x. So for this undetermined solution, we need to determine the value of a. So for this we need to integrate it twice. So if we will integrate it, so y p prime, so it will be ax square times minus 1.5x into e power minus 1.5x, and then plus 2ax into e power minus 1.5x. So basically we have applied the product rule for this differentiation. For y double prime p, you can do that, and after simplification it will be 2.25 ax square e power minus 1.5x minus 6a x e power minus 1.5x plus 2a e power minus 1.5x. Okay, so now we have y double prime and y prime p, and the equation is y double prime plus 3y prime plus 2.25y. So for this, if we can add 3y prime to that, so it will be minus 4.5 ax square. Yeah, multiply this equation by 3. Okay, so it will be minus 4.5 ax square e power minus 1.5x plus 6a x e power minus 1.5x. Okay, and then you can add also plus 2.25 y, that means this one, so it will be plus 2.25 ax square e power minus 1.5x. So now if I can visually add these three values, so these three terms will cancel out, and then similarly these two terms will cancel because this was minus 6, this was plus 6. So the term remaining will be 2a, this one. This term will remain. This term will remain. So 2a e power minus 1.5x yeah, so in this way then we can add these values. So we will get 2a e power minus 1.5x is equal to minus 10 e power minus 1.5x. So the value of a we will get is minus 5, and the general solution will be this. So from this general solution now we can find the we can apply the initial values over here. So initial value y0 is equal to 1. So 1 is equal to c1 plus that term will be 0, and this term will be 1, and this term will be 0. So c1 is equal to 1. Now we can find the we can apply the second initial value. Y prime is equal to y prime 0 is equal to 0, y prime 0 is equal to 0. So it will be then y prime can be found like differentiated. So it will be c1 plus c2 plus c2x into minus 1.5 e power minus 1.5x. Then the next term will be, because take the derivative of this will be c2 only, c2 into e power minus 1.5x. And the last term, yeah, we can take the derivative, but both will include x. So both term, if we will put y0 is equal to 0, then both term will give you the answer as 0. So I think I don't need to calculate it because it involves x square. So x will always be there when you will take the derivative. So just to save some time, I already know that it will be 0 when I put these initial values. So 0 is equal to, this will be c1, that term will be 0. So it will be c1 times minus 1.5, and this term is 0. So, and then c2, and then this term will be 1. Sorry, this term will be 1. Because this term will come from e power minus 1.5x, so that will be 1. So now you have, now I have 0 is equal to minus 1.5 c1 is plus c2. So c2 is equal to 1.5 c1. That means c1 is equal to, we know that is c1 is 1. So means c2 is equal to 1.5. c2 is equal to 1.5. So therefore we have the final answer with initial value problems already considered. So y is equal to c1, which was 1, plus c2, which is 1.5x into e power minus 1.5x plus this, so it is minus actually minus 5x square e power minus 1.5x. So we can combine these terms, 1 plus 1.5x minus 5x square into e power minus 1.5.